You know, in the world of international cyber espionage, it's this high stakes game of cat and mouse, right? And sometimes just one tiny mistake can bring the whole house of cards down. That's exactly what we're looking at today, how one developer slip up gave us this incredible peek inside one of Iran's top hacking units.
All right, before we dive in, I just want to be super clear about where this info is coming from. This entire breakdown is based on some fantastic research from the Synaptic Security blog, and we've also pulled in data from the well-respected MITRE-ATT&CK framework.
So that really begs the question, doesn't it? What actually happens when a super sophisticated, state-sponsored hacker just gets a little bit lazy? Well, as we're about to find out, the fallout can be, well, massive. Okay, so to get to the bottom of that question, we need to meet the players. And in this story, our main character is a cyber espionage group known as MuddyWater. Now, it's absolutely crucial to get this. MuddyWater isn't your average hacker group hanging out in a basement. No way. These guys are a mature, state-aligned operation, and they're attributed directly to Iran's Ministry of Intelligence and Security, the MOIS. And look at their targets: governments, defense contractors, major telecom companies all over the world. We're talking about a serious, top-tier threat actor, which is what makes what we're about to see so absolutely mind-blowing. So where did this all begin? It all kicked off with something you've probably heard of a million times: a malicious Microsoft Word doc. Yep, a classic phishing email. It's a super common tactic, right? But what was hiding inside this particular document was anything but ordinary. So, if you're a malware analyst and this lands on your desk, your first steps are pretty standard. It's almost like a routine. As you can see here, you'd probably start by running a tool called OLIdeed, just to check out the file's structure. Then you'd use something like OLIVBA to poke around at the macros embedded inside. The whole goal here is pretty simple: find the bad stuff, piece it back together, and pull out the malicious payload. And after digging through a bunch of junk code, and trust me, there is always junk code, the macro's real purpose came into view. And it was surprisingly simple. It just wanted to run one single command. That's it. It would call up cmd.exe to launch this file, certificationkit.ini, that it had sneakily dropped into the program data directory. Okay, so once that hidden file is extracted, we can identify it using its unique digital fingerprint, what we call a SHA-256 hash. And a quick search of this hash confirms our suspicions. It's a known MuddyWater tool, a variant of an implant they use to steal information. So up to this point, everything is going exactly as expected. It's textbook MuddyWater analysis. But this is the moment. This is where a totally routine investigation takes a wild, unexpected turn. This is the aha moment, where one tiny overlooked detail changes absolutely everything. You know, one of the very first things an analyst does with a new piece of malware is kind of like digital archaeology. You're just looking for any readable text, we call them strings, that might be left inside the code. You're hunting for clues, really. Anything at all that could give you a hint about what it does or who made it. And there it was. Buried deep inside the malware's code was this file path: C:users Jacob. Now, this was never meant to be seen by the public. This is a leftover artifact from the developer's own computer. This right here is the mistake. This is the lazy operational security, the OPSEC failure that just blows the entire case wide open. Think about that for a second. That one single string of text, that one little reference to Jacob, is like opening a window and looking directly into the developer's workshop. It's the first thread you pull that starts to unravel a much, much bigger story. And from these digital breadcrumbs, we can start to build a surprisingly detailed profile of our developer. I mean, just look at this table. The C.users Jacob path, that tells us right away the malware was built on a Windows machine. Then we find other strings like stable-x64-pc-windows-msvc. That's a huge clue. It means they were using Microsoft's own Visual C++ compiler, not cross-compiling from Linux or something. And then you see paths like .cargo.registry. That points to it being built on a local dev machine. This wasn't some polished professional build server. This was likely just a guy at his computer hitting compile. It's pretty clear that getting the tool out the door was way more important than hiding their tracks. And the leaks just keep on coming. The malware had even more paths that basically gave away its entire internal source code structure. We can actually see the file names: a main file, main.rs, and then separate modules for persist.rs and interface.rs. This tells us it's a pretty well-structured tool, right? It has dedicated code for making sure it stays on a system and for talking back to its command and control server. This is a full-featured implant, not some quick and dirty script. And then, if you can believe it, it gets even better. The developer even left behind the commit hash of the Rust compiler they were using. I mean, that is just a gift to investigators. It lets them pinpoint the exact version and even the date of the toolchain they used. That kind of information is priceless for tracking how their malware evolves over time. Okay, so we've got a username, compiler versions, file paths, but you might be wondering, why do these little technical details matter so much? What's the real strategic win here for the defenders? This slide really lays it all out. See, defenders usually track an attacker's infrastructure, their C2 servers, their domains, but here's the problem. An attacker can switch those out every single week. It's trivial for them. But these build artifacts, the username Jacob, those specific file path, that compiler version, that's different. That's part of the developer's core workflow, their environment. To change all of that, that is much, much harder. It's their digital fingerprint, and it's a lot harder to change than a server IP. And that brings us to this key takeaway from the original analysis. It puts it perfectly. Tracking infrastructure is like tracking a car's license plate. Easy to swap out. But tracking these build artifacts, that's like tracking the factory where the car was built. It's a fingerprint that sticks around across multiple operations, through multiple campaigns. So what Jacob failed to do is a process we call build sanitization. This is like DevOps 101 in any mature software shop. It's the step where you strip out all this identifying metadata, usernames, debug info, file paths, before you ship your code. The fact that MuddyWater's malware wasn't sanitized tells us a lot about their internal processes. It points to a team that's maybe rushing, one that values speed over careful, secure operations. So in the end, what does one developer's simple mistake really tell us? It's a powerful reminder that even these big, sophisticated state intelligence agencies are ultimately run by people. People who get rushed, people who get lazy, and people who make mistakes. And for the good guys, for the defenders, a mistake like this is an incredible gift. It's this rare and valuable look inside the workshop that gives us clues that will last a whole lot longer than any temporary server address. Hey, if you found this breakdown as fascinating as I did, do me a favor and hit that like button and subscribe for more. It really is a huge help, and it's what allows us to keep making more explainers just like this one. Thanks so much for watching.